Hello all. We all know about pi. Pi is a concept that has troubled us and still troubles us to this day. We celebrate Pi Day on the 22nd of July. Do you know why? Because the earliest fractional value of pi is 22 by 7. Isn't it interesting? But we also celebrate pi on two different days. On the 14th of March, the third month of the year. Because the earliest decimal value of the pi is 3.1417 and so on. Pi is a concept that gets interesting as it goes on. There's many wide variety of applications, many variety of complex histories, etc. It also gives us many marvelous, wonderful structures around the world. Let's get to know more about pi.
The best known approximation of pi dating before the Common Era were accurate to 2 decimal places. This was improved upon the Chinese mathematics, in particular by the mid-first millennium, to an accuracy of 7 decimal places. Based on the measurement of the Great Pyramid of Giza, some Egyptologists have claimed that the ancient Egypt used an approximation of pi as 22 by 7 from as early as the Old Kingdom. This claim has been met with skepticism. The earliest written approximation of pi are found in Babylon and Egypt, both within 1% of the true value. In Babylon, a clad tablet dated 9000 to 6000 BC has a geometrical statement that by implication treats pi as 25 by 8 is equal to 3.125.
The calculation of pi was revolutionized by the development of infinite series techniques in the 16th and 17th centuries. Infinite series is the sum of the term of an infinite sequence. Infinite series allowed mathematicians to compute pi with much greater precision than Archimedes and others who used geometrical techniques. The first written description of an infinite series that could be used to compute pi was laid out in Sanskrit verse by Indian astronomer Neelakanta Somayaji in his Tantra Samgraha around 15,000 AD. Neelakanta attributes the series to an earlier Indian mathematician, Madhava of Sangamagrama, who lived from 1350 to 1425. Several infinite series are described, including series for sine, tangent, and cosine, which are now referred to as the Madhava series or Grigori Leibniz series. Madhava used infinite series to estimate pi to 11 digits around 14,000, but that value was improved on around 1430 by the Persian mathematician Jamshid al-Khashi using a polygonal algorithm. Not all mathematical advances relating to pi were aimed at increasing the accuracy of approximations. When Euler solved the Basel problem in 1735, finding the exact value of the sum of the reciprocal squares, Swiss scientist Johann Heinrich Lambert in 1768 proved that pi is irrational, meaning it is not equal to the quotient of any two whole numbers. French mathematician Adrien Marie Legendre proved in 1794 that pi square is also irrational. In 1882, German mathematician Ferdinand von Lindmann proved that pi is transcendental. Hardy and Wright states that the proofs were afterwards modified and simplified by Hilbert Hurwitz and other writers.
The developments of computers in the mid-20th century again revolutionized the hunt for digits of pi. Mathematicians John Wrench and Levi Smith reached 1120 digits in 1949 using a desk calculator. Using an inverse tangent infinite series, a team led by George Reitwiesner and John von Neumann that same year achieved 2037 digits with a calculation that took 70 hours of computer time on the ENIAC computer. Two additional developments around 1980 once again accelerated the ability to compute pi. First, the discovery of new iterative algorithms for computing pi, which were much faster than the infinite series, and second, the invention of fast multiplication algorithms that could multiply large numbers very rapidly.
Value of pi is the ratio of the circumference of the circle to its diameter. The approximate value of pi is 3.14159. In a circle, if we divide the circumference by the diameter, we get exactly the same number. Whether the circle is big or small, the value of pi remains constant. It is named after the Greek mathematician Archimedes. He devised a method for calculating the pi value. That's why pi is often referred to as Archimedes constant. Furthermore, the value of pi in fraction is 22 by 7. It has an infinite number of digits beyond the decimal point. Thus, it is an irrational number. Using the longer form of pi may lead to difficult in calculation because the longer form of pi is 3.145926 535897932338 and so on. Therefore, 22 by 7 is used for everyday calculation. Do you know the value of pi in trigonometry? The value of pi in trigonometry is 180 degrees and we represent pi in degrees to calculate the angle of radians.
Pi is closely related to circles and are found in formulas of geometry and trigonometry where there are figures like circles, spheres and ellipses. Other branches of science like physics, Fourier analysis, statistics and number theory also include pi in their major formulas. Pi is used to find the area and circumference of a circle in basic mathematics. Pi appears in formulae for area and volumes of geometrical shapes based on circles such as ellipses, spheres, cones, etc. Some of the more common formulae that involve pi are: the circumference of a circle with radius r is 2 pi r. The area of a circle with radius r is pi r square. Anything which has a diameter and a circumference can pi be applied to it. Pi can be found in the rainbow, the moon, the sun, the pupil of an eye and in the falling raindrop.
Hope you got to know more about pi. Isn't pi an interesting subject which has many various fields of applications and can be used in various fields of works, and even in the single drop of life contains an application of pi in it. Hope we get to see you again next time. Bye.